what if you could watch our entire planet change, not just in yearly snapshots, but like a continuous, non-stop movie? I mean, really imagine seeing a forest disappear or a city expand, not years after it happened, but almost in real time. Well, today, we're going to pull back the curtain on the brilliant algorithm that actually made this possible. So let's start with the big question. How do we get a daily report card for planet Earth? For decades, this was the central challenge for scientists. We need to know what's happening on the ground everywhere all the time. But how in the world do you actually do that?
And let's be clear, the stakes for getting this right are, well, they're incredibly high. This isn't just about making cool maps. It's about managing the very planet we live on. I mean, think about it. We absolutely need this data to track the heartbreaking pace of deforestation, to manage how our cities are just exploding in size, and to build accurate models for climate change. To do any of this well, we need a constant, clear view of what's happening. But here's the thing. For the longest time, getting that clear view was a massive headache. The way we used to do it, honestly, it was slow, super expensive, and just kind of broken.
Okay, so check this out. The difference is just night and day. The old way was all about hunting for a few perfect pictures, these pristine, totally cloud-free images. Which sounds great, right? The problem? You might only get a shot like that once every couple of years. The CCD way, though, it's a totally different mindset. It builds that non-stop movie by using all the data, even the messy bits.
And the scale of this problem? It's kind of staggering when you think about it. For decades, the rule was simple. Only use the perfect images, the ones with less than 10% clouds. But get this, that meant we were literally throwing away more than half of all the perfectly good, clear pixels just because they were in a photo that was a little bit cloudy. We were just tossing out most of our data. It's wild.
So, the biggest villain in this whole story? Yep, clouds. This obsession with perfect pictures meant scientists had to ignore most of what their satellites were seeing. The result? Our report card for the planet was coming in years late, and it was just riddled with blank spots.
But then, this is where the story gets really good. A team of scientists basically decided to flip the whole problem on its head. They had this realization. Maybe the solution wasn't about finding perfect pictures. Maybe it was about getting smarter with all the messy ones we already had.
And this was the big, game-changing question they asked. What if? What if we just stopped this endless hunt for perfect photos? What if we used every single clear pixel from every single image, even the cloudy ones? What if all that messy data wasn't the problem? What if it was actually the solution?
And right there, that idea is what led to the CCDC algorithm. It stands for Continuous Change Detection and Classification, but what it does is the cool part. It basically rescues all those millions of pixels that we used to throw away, and it uses them to build this incredibly detailed history for every little 30-meter spot on the planet. Okay, so how does this thing actually work? I mean, how do you turn a jumbled mess of pixels into a clear story? Well, the concept behind it is it's really elegant.
It all comes down to something called a time series model. But honestly, the best way to picture it is to think of it like a doctor who's monitoring the heartbeat of the planet. For every single little patch of land, the algorithm just starts by listening. It learns the normal, seasonal rhythm, its heartbeat. So take a healthy forest, for instance. The model learns its predictable heartbeat, right? It gets greener in the spring and summer, it gets browner in the fall and winter. The usual. And it uses all that data to figure out, okay, this is what normal looks like for this specific spot. And it just keeps tracking that heartbeat, day after day, year after year, until something changes, a fire maybe, or a new building goes up. All of a sudden, the signal, that heartbeat, breaks from the pattern it expects, and the algorithm goes, aha, something just happened. It flags it immediately. A change has been detected.
So, if you boil it all down, the whole process is really just 4 simple steps. Step 1, you grab all the data you can, every clear pixel. Step 2, you clean it up. Get rid of the obvious noise like clouds and shadows. Step 3, you teach the model the normal heartbeat for that pixel. And then step 4, you just watch and wait for a break. That moment when what's actually happening on the ground doesn't match what the model predicted.
Now you might be thinking, what if it's just a fluke? A weird shadow or something? Well, the algorithm is smart about that. It's patient. It doesn't just jump the gun. It actually waits for the signal to break that pattern 3 times in a row. Once that happens, then it's confident that, yep, a real change has happened down there.
So, the big question is, does it actually work? Well, the results from the very first study back in 2014 were honestly a total game changer.
They really did turn decades of messy, noisy data into this crystal-clear history of how the landscape was changing.
To test it out, the researchers picked a spot in New England, which, by the way, is famous for being cloudy, so it was a tough test. And they didn't hold back. They threw a whopping 519 Landsat images at the algorithm, covering almost 30 years of data.
And the results? Just stunning. The maps that CCDC produced, telling you if a spot was a forest or a city or water, they were 90% accurate. That's a huge, massive leap forward for mapping our world. But honestly, this next part is even more impressive. The algorithm was 80% accurate at pinpointing exactly when a change happened. Think about that. It wasn't just saying, oh, this forest was cut down sometime in the mid-2000s. No, it was saying the change happened right here on this date when this satellite passed over. That's a whole new level of detail.
So when you put it all together, this is the real payoff. We can now, for the first time, create a map for pretty much any day in the last 40 years. We can see what the land was before the change and what it became after. We basically have what we talked about at the beginning, a non-stop movie of our planet. And that lets us answer questions we could never even think to ask before.
And this isn't just a history lesson. Today, we have new satellites that are sending back a constant flood of data. It's like a fire hose of information. And CCDC is the engine that's making sense of it all. It's turning that raw data into a near real-time picture of our world as it changes, moment by moment.
Which brings us to one last, really powerful question. We now have this incredible ability, something no one in history has ever had, to see our planet changing pretty much as it happens. So the big question isn't really what's going on down there anymore. The question we all have to face now is, what are we going to do about it?